first, the start of factoring, kind of factor polynomials. And it turns out that this greatest common factor is by far the most important type of factoring for polynomials. And in fact, other things, you can factor other things that are not just polynomials, and GCF turns out to be super important for all of that. So let's see what that looks like. So the basic idea goes something like this. Let's say I have a polynomial, very simple one, 3x minus 12, right? So both of these terms have a 3 in them, right? 3 is in 3x and 3 is in 12. And so I want to think of this as like 3 times x minus 3 times 4. Right, and then I'm going to undistribute. Essentially, that's really what factoring is the opposite of distributing. If you remember from the previous topic, multiplying polynomials was really just a bunch of distributive property, and that's what we're doing here. But the other direction, we're undistributing, so we're like unmultiplying essentially, not dividing. It's not like the inverse operation of multiplying, but we're undoing the division, or we're undoing the multiplication. So yeah, so I'm going to write this as 3 times x minus 4. Right, if I were to distribute this in, I would get back to where we started from. So that's really what factoring is. It's undoing multiplication. So there you go. That's greatest common factor. What I'm going to do is I'm going to look for the biggest thing that's in all of the terms of the polynomial and pull it out front. And that is super helpful to do. And you won't see why it's super helpful yet. But when we do some more factoring, you'll see why it's helpful. And the farther you go in math, the more you'll see how valuable this is. Like, for instance, when I teach my Calculus 2 students how to do, well, there's a bunch of stuff that I teach them how to do. But one of the first things we go over is how to factor this. More complicated, in a more complicated setting, but it's the same basic idea. So yeah, this is not a thing that will go away. So anyway, let's see another example. Let's say I have 10 x squared y minus 15xy squared plus, I don't know, let's say 100 xy. All right, so what I'm looking for here is I'm looking for the most stuff that is in all of the terms, right? And so 10x squared y, I'm just bear with me while I write this all out in ridiculous detail. So this is going to be 2 times 5 times x y, and 15, so I'm going to have minus 3 times 5 times x times y, plus, and then 100, if you don't know, you can do a factor tree to see it, but it's 2 times 2 times 5 times 5 times x times y. And so when I look at this, I want to identify the stuff that is in all of the terms, each of the factors that's in all the terms. Let me highlight this in red. And so when I look, I can see that I've got a 5 in all of the terms. I don't quite have a 2 in all the terms, because there's no 2 in the 15. And I have at least one x and at least one y. So I'm thinking that there's going to be a 5 in each term, or I can see that there's a 5 in each term. There is at least one x in each term and at least one y in each term. And there's nothing else. So when I look at the stuff I didn't circle, I've got a 2 and a 3 and 2 2s and a 5. All right, excuse me, a 2 and an x and a 3 and a y, 2 2s and a 5. And none of those things are common to all 3 of the terms. Right, and so I've got everything I can pull out. So the most I can pull out here is a 5xy. So that's what I'm going to do. I'm going to pull 5xy out. When I say pull out, what I really mean is undistribute. And then whatever's left is what goes in the parentheses. Now, the way you want to think of whatever's left is, what would I have to multiply 5xy by to get 10x squared y? Well, it's the stuff that I didn't circle, right? 2x is is what 10x squared y is missing, or excuse me, what 5xy is missing to make 10x squared y. So that's what goes here, is 2x. Similarly here, I've got a minus 3y left over after I pull out 5xy, minus 3y. And here I've got 2 times 2 times 5, which is 20, and that's it. There you go. That is greatest common factor. Now, You don't always have to pull out a positive number. You can always pull out a negative number if you like. And you might ask yourself, why would I ever do that? And the answer is to make the stuff inside the parentheses look the way you want it to, which we'll see a little bit in the next topic when we talk about factoring by grouping. We'll see it a lot, actually. But so, for instance, let's say I have minus 15y to the third plus 9y squared minus 3y. So something like that. Very often you'll want your leading coefficient to be positive. And so in this case, I think it's actually best to pull out a negative greatest common factor, which is totally fine. You can always do that. All it does is change the signs. Like, for instance, I could have pulled out minus 5xy here if I wanted to, and that would have made this minus 2x plus 3y minus 20. All it does is change the signs inside. And so I'm going to pull out a negative 3y here, since every term has a 3 and every term has a y. I think that's all of them. So that will leave me 5y squared minus 3y plus 1. And notice that that we have to watch these signs, right? And like this needs to be a minus, so that when I go minus 3y times minus 3y, that gives me plus 9y squared. That's when I pull a negative out of a positive, it leaves me with a negative. That's pretty much that's pretty much all there is to that. Now, your greatest common factor doesn't necessarily have to be just a monomial like this. It can be something else. Like, for instance, let's say I have 2x times x minus 1 plus 3 times x minus 1. The thing that's in common here, and the way you want to think of anything in parentheses, is that thing in parentheses is all one piece. So this is one piece. That's one factor there. And so is that. And of course, that's common to both terms, so I can pull it out front. And so when I do that, I get x minus 1, and then what's left over inside is 2x from the first term there, and a plus 3 from the second term. So you don't have to limit yourself to just pulling out monomials. You can pull out binomials or trinomials or whatever is common to the term, or whatever is common to every term. You can pull out other things, like we'll eventually do this with exponentials and other stuff. So anything that's common to every term in a polynomial can get pulled out at the front, even if it's not just like a 3 or like a 2x or something like that. Even more complicated stuff can get pulled out. Now, let me just briefly remind myself if that is what I wanted to talk about. And yeah, I think I've got everything there. So I'm going to go ahead and stop the recording right there, and I will see you guys in the next one when we learn to factor by grouping by doing a bunch of greatest common factor. All right, see you then.